All right, so today you want to look on the last page of your yellow note packet here. And what we're looking at today is energy and change. Energy and change. All right, most changes involve the flow of energy from one part of the environment to another. So if you think about most types of changes, it could be like water evaporating, all right? Well, that involves energy. A puddle on a sunny day, evaporates faster than a puddle on a cloudy day because the sun's energy goes to the water and then makes that water turn into a vapor, all right? That's just one example, all right? Most changes involve the flow of energy from one part of the environment to another. Okay? Now, an interface is a boundary between two regions with different properties. So if I look over here, my examples, kind of imagine that I have like a beaker, and beaker, I have water and it's air up there. Now, water is a liquid, H2O, air, a gas made up mostly of nitrogen and oxygen. So they have different phases and they have different chemical compositions for the most part. Now, the boundary between the two, so the top of the water and the bottom of the air, that is the interface. So an interface is a boundary between regions with different properties. Now, the exchange of energy in the process of change frequently happen at an interface. Right? Now, using the example that I just said a minute ago with water evaporating, well, just think about here. Let's say I have some warm water right there and there's some cold air right there. Right? There's a few changes that can take place right there. One change that can take place is that the energy from the water will move to the air. So the water will lose some heat and the energy will move to the cold air and the cold air will gain some heat. All right, but where is that energy flowing from one region to the next? Well, it's happening right there between the two. It's happening at the interface. Another change is the water evaporating. So right there, I have the warm water and the cold air. The warm water is going to turn into water vapor that goes into the air. Where is that water evaporating? It's not the water at the very bottom of the container that's evaporating. It's the water right there. The boundary between the two right there is the water that's evaporating. So the exchange of energy and the process of change frequently happen at the interface. Now, when we study change, what we notice in the environment is that most changes in nature are part of a dynamic equilibrium. All right? Now, dynamic equilibrium, what's that? Well, let's break it down. Dynamic means something that's very active and changing. Equilibrium means something that's nice and balanced. So those two words kind of seem like they are kind of like the opposite of each other. I have something changing that's balanced, all right? So what a dynamic equilibrium is, it's when changes take place on a small scale, but the overall situation is the same. So there's lots of changes happening, but something stays in balance for the most part, all right? Give you an example. All right, so what we have over here is a map that's a nautical map, and it has the two biggest Finger Lakes. It has Shymkiw Lake and it has Seneca Lake. All right. Now, Seneca Lake, at the very bottom of Seneca Lake right there, there's Catherine's Creek. Catherine's Creek is a river, or a stream rather, that flows into the lake. So water being added to the lake is a change, all right? Right there in Dresden, New York, there's the Shymkiw outlet. It's another stream that flows into Seneca Lake. Water being added to the lake is a change. Down here, you get the Hector Falls, which is a which is like a stream, a big waterfall that empties water into the lake. So it's another change with water being added to the lake. When it rains, all right, water flows straight into the lake. There's also, which is a change, there's also groundwater flowing into the lake, which is a change. And there's also, runoff from the sides of the hills and so forth, with water going into the lake. That's a change. So there's a whole bunch of changes that are adding water to the lake. But there's also changes taking place that remove water from the lake. Up here, near Geneva, is a river that flows out of Seneca Lake, the Seneca River. The Seneca River removes water from the lake. So taking water out of the lake is a change. You also have water evaporating, so going straight from the surface of the lake back up in the air. That's a change. So there's a bunch of changes where water's being added to the lake, and a bunch of changes where water's being taken out of the lake. But the overall lake level really doesn't change that much. I mean, Seneca Lake's a very deep lake. The deepest spot's like 620 feet, so it's a really, really, really deep lake. But even when swings from really rainy times to real dry times, the lake level might only fluctuate a couple feet. So 2 feet out of like 620 really is a pretty small fluctuation. So this would be an example of a dynamic equilibrium. Lots of changes add water to the lake, lots of changes take water out of the lake, but overall the situation is the same. So that would be an example of a dynamic equilibrium. Now, so in nature, most things are dynamic equilibrium. Things that can happen to throw something out of whack. Well, human technology does a pretty good job of upsetting dynamic equilibriums. And just to give you one example, it's kind of similar to what I just showed you there with Seneca Lake, is in Asia. In Asia, there is a giant sea called the Aral Sea. All right. Now, the Aral Sea has a bunch of rivers flowing into it. So there's a bunch of water flowing into the Aral Sea, but what makes it different from Seneca Lake is Seneca Lake has streams flowing into the lake, but there's also streams flowing out of the lake. Here, there's streams flowing into the lake, or into the sea, but really the only way it loses water is by water evaporating off of it. So water flows in, water evaporates. All right. Now, this is a very big sea. There were villages built on the side of it. They relied on fishing, so they had lots of fishing fleets and other industry associated with that. So they had like canneries, so like fishermen would go out there, catch the fish, and then bring them back, and they'd be canned here and sent off to other parts. This at one time was in the Soviet Union. Right? So things are going pretty good. But what happened is this region is pretty dry. The ground's fairly fertile, but the area is pretty dry. And one of these rivers that flowed into the Aral Sea, what they decided to do is back here, they wanted to start growing cotton. Now, cotton's a very valuable crop. So the area's pretty dry, so what they decided to do is to dam up and divert this water. So this river that used to go into the Aral Sea, they're going to divert a lot of that water and make it, use it for irrigation and water these cotton fields. So they dam it up, so there's only a small fraction, so you end up with a lot of the water back here now. And this water here is being used to water these cotton fields back here. So what happens is a lot of the water that was flowing into the lake or into the sea is not flowing in there anymore. All right. Now, the sea is still evaporating a lot of water, but now, because so much of the water is cut back here to water the crops, not as much water is going in. So you're still losing a lot, but now you're not gaining as much. So what happens as time goes by, more water evaporates is going in, so the sea shrinks and shrinks and shrinks. So now, over the course of around 30 years or so, the sea shrunk. Right now it's about like 10-15% of its original size. All right, there's only, and the other thing that happens is not only is the sea shrunk quite a bit, but what else happens is that like if I have salt water and I put it out there, the water evaporates, the salt gets left behind. So if let's say I have a gallon of salt water and I let half the water evaporate, the half that's left becomes twice as salty because the salt doesn't go up in the air, the salt gets left behind. Well, kind of the same idea here happens here, is so much of the water evaporates that the salt that was in the water gets left behind, and that becomes saltier and saltier and saltier and saltier, and it's so salty, in fact, that a lot of the fish that once lived in there can't live in there anymore because the water's so salty. And another thing, look where these fishing villages are. These fishing villages are now nowhere near the sea. So it's causing some massive economic problems there. This area here is becoming kind of like a salt, it's like a salt desert out here. There's images of like the old fishing fleets are just kind of sitting out in the desert now. And it's causing all sorts of problems. And something that kind of makes the problem even worse is these aren't even in the same country anymore, because once the Soviet Union broke up, what's happening over here is in a different country that's what's happening over here, which it complicates the matters more because these people are happy having this water back here and growing their cotton, but it's making things bad over here, but they're different countries. So what you have though is something that was once in a state of equilibrium, once in a state of dynamic equilibrium, was thrown out of whack by the human technology, them building a dam and diverting a lot of the water away from flowing into the Aral Sea, took something that was pretty well balanced and threw it out of balance, and now it's all messed up there. It's a big environmental disaster. Okay? So human technology can disrupt the environment in major ways. Right? Another thing that there isn't natural forms of it, but humans definitely play a huge role in it, is pollution. All right? Pollution is when the concentration of matter or energy reach levels that are harmful to living things. Now, humans play a big role in this. Now, there are some types of natural pollutants. All right? Pollen, in some instances, could be considered a pollutant. Volcanic ash. There's different types of volcanoes. The ones you normally think about are the ones that like erupt in Hawaii that have the red lava flowing down the side. That's one type of volcano. The other type of volcano is one that spews like these big giant, what looks like clouds coming out of the volcano. That's really volcanic ash, which is kind of like this dust material. But the thing is, it goes up in the atmosphere, and when it gets up there, it spreads out, depending on the wind, it can spread out over a large area, and like animals could breathe it in and choke, and then the ash covers the leaves of plants, blocks out the sunlight so it could kill plants that way. So there's a variety of ways in that volcanic ash can kill things. All right. Now, just the presence of something doesn't necessarily mean it's pollution. To be a pollutant, it says when the concentration of matter or energy reach levels that are harmful to living things. So like just a little bit of volcanic ash wouldn't necessarily be considered a pollutant. Because a little bit of volcanic ash isn't going to cause damage. But lots of volcanic ash would be considered a pollutant. So there are some forms of natural pollutants. But by and large, most of the pollutants that we have in the world are ones that are man-made. And this is just a tiny fraction of the type of pollutants I could list here. All sorts of chemicals, all right? For example, like carbon dioxide. Now, carbon dioxide does happen naturally. However, whenever we burn stuff, like trees or oil or coals, things like that, it produces a lot of carbon dioxide. And high levels of carbon dioxide in the atmosphere can be negative to living things. But there's all sorts of other chemicals. You can include chemicals that are getting put in the water, can poison the water. Again, if there's just a tiny amount of the chemical, that doesn't necessarily mean it's a pollutant. It has to be enough of it where it has a negative effect on living things. Smoke could be considered a pollutant. Again, it can choke things out, block out the sunlight. So it can have a variety of negative effects. Radiation. So probably the most famous example of that would be in the former Soviet Union in Chernobyl, where there's a nuclear power plant that underwent a meltdown. So the area around Chernobyl, that's a little over 35 years ago at this point. But anyways, a lot of the creatures and stuff that are in the area, a lot of them have mutations and like birth defects and stuff like that because the radiation level's so high. And also, more recently, was it like 2012, I think, in Japan, there was a big earthquake which triggered a tsunami, which caused a meltdown in a nuclear power plant. And there's real high levels of radiation around there too, which can have a negative effect on creatures, because radiation can cause mutations, and a lot of mutations can lead to cancer and so forth. Heat. Heat by itself can be a pollutant. I worked a couple summers in a bottle factory. It was a glass bottle factory. And glass, for the most part, is a fairly clean industry. It's basically melting sand. But one of the things that happens, though, you have a lot of molten sand, and water is used to cool some of it. So you have a lot of really super hot water. Now, what they would normally, the company I was at, what they normally do is they have like a holding tank. So the hot water goes in this holding tank, and then it would cool down, and then eventually it would get released, and there was a nearby stream. Well, one time, something happened, and it was supposed to go in the holding tank, but it went from the holding tank right into the stream. So you had this really super hot water, which was boiling, near boiling, and it went into a stream. Well, the fish that were in the stream didn't really appreciate that, so it killed a bunch of fish because of the really high temperatures. Now, as far as pollutants go, that wasn't that bad, because as soon as the water cooled down, it was fine. But while the hot water was being put into the stream, it was technically a pollutant because there was enough energy in there to kill things. Sound. Sound can be a pollutant as well. With really noisy factory. If it gets really, really loud, it can disrupt animals too. So normally you think of pollutants, you think of like chemicals and smoke, but there's also other things that could be pollutants as well. All right. All right, that is energy and pollution.